What's going on, everybody? Welcome to CS540 week 9. If you're new here, welcome. Be sure to check nannyblog.com and go to this link here. Then you're able to view this page. So in this week, we are talking about the propositional logic. So for this week, I would like to divide this topic into two parts. So the first is just the basic about what is the propositional logic, what's their science, and also an introduction about the knowledge base. So what should we do with those propositional logic and knowledge base, and what are the ways to solve that, and also some logic rules and equivalence. So those are just the formula that we can use. So let's just get started. So first of all, we are going to talk about the signs here. So there are many 5 signs that we are talking about here. So the first sign here is not. So if we can do probably use the capital one. So this sign is in front of all kind of logic. So here, if Q is false, let's say Q is false here, then this will be the opposite, which is true. And if Q is true, then the negation of Q, of course, is false. So it's pretty intuitive. Next is AND. So this is AND. So what is used is between two different logic. So here, if both A and B are true, then this formula here is true. If any of them or both of them are false, then this is false. So this is AND. The third is OR. So if any of A or B or both of them are true, then this equation is true. If both of them are false, then this equation is false. So I think the previous 3 are really easy to understand. I think the fourth one is somehow a little bit difficult. So the fourth one is called if then, and it's also used between different logic. So let's take an example here. Let's say you want to get a grade in for example, a course, let's say CS40. So as we know, we have a lot of quizzes, midterms, homework, and final. And if we want to get an A in this class, then let's just make an assumption that we have to get an A in final. So if you do not get an A in final, no matter how well you did in all previous exams and homework, you still cannot get an A from this class. So here, the A, let me change the color. So the A is to get an A in class. So this capital A here represents the thing that we get an A in class, and B here is we get an A in final. So let's say for the if then is by given the condition that A here is true, whether or not the B can satisfy or not. So let's say if we get let's say A is false. Probably I should avoid this sign here. So A is false. That is, we didn't get an A from the class. So whether we can get, is it possible that we get an A in final? The answer is we don't know. It can either be we get an A in final, or we didn't get an A in final. If we didn't get an A in final, of course, we cannot get an A in the class. So the B is false. And if we get an A in final, but if we did pretty bad in the midterms and homework, we still cannot get an A in this class. So the B can either be true or false. However, if we get an A in the final, then we have to get we get an A in this class, then we have to get an A in the final, since this is the requirement. So this is true. However, if we get an A from this class, but we didn't get an A from the final, which is B is false here, then this isn't true. So if B is true, if B is false, then this doesn't make sense. So that is the condition of false here. So let me just erase this. So by giving the condition of A and B, and here is A, if A then B. So if A is false and B is either false or true, then this formula here is true. If A is true and B is true as well, it's still true. If A is true and B is false, then this is false. So just pay attention to this kind of notation here. This is a little bit tricky, and later when we talk about the equivalence, this if-then sign is pretty important. Last but not least, we are going to talk on this equivalent sign. So it's also used between two different logic. So if A is true and B is true, then A equals to B is true. So only if both of them are true, then both of them are the same, then it's true. So it's somehow like kind of a equivalent sign in C or in Java or in Python. And if they are different, then it's false. So this, I believe, is also very intuitive. Next, I would like to talk about the precedence of these signs. So the precedence of negation sign here has the highest priority, and it will decrease from here. So first it will have this, then and sign, then or sign, then if and sign, then equivalent sign. So this is their precedence. And next is about the syntax. So if you have something like, you cannot have two different logic sign at the same time. So for example, no one understands what does this mean. So you can only have one sign between different logic. So the symbol here presents on different logic. So you can only have one between each of them. And another thing is, like, no one can understand what this means neither. So if A is true, then B is true, then what? Then here actually it has no meaning. And another thing here is, in order to change the sequence, for example, if something like this, then we will regard it as first not A or B. However, if we want to have negation of the negative or of A or B, then we just have a bracket here. So we will execute the things in the bracket first, then go outside. So these are just some basic propositional logic signs here. And next, I would like to talk a little bit about some terms to describe the logic equation. So there are actually three different notation. Oops. First is the satisfiable. Sorry. The second is unsatisfiable, and third is valid. Or you could say it as, how do you say that? Tautology. So if a equation it has some value to be 1, and it also have some value to be 0, then we call it satisfiable. If all of the true and false table are 0, then we will say it is unsatisfiable. And if all of them are 1, we call them valid. So these are just some terms here. Next is knowledge base. This is really, really important. Like normally if we have exams on this topic, then I would say like 90% they will give you a knowledge base and do something. So knowledge base, or we could say KB, is it will give you a lot of like conditions or the things that we already understand. So for example, if you guess A and B, the question can also give you like A or minus B, something like this. So they will give you a lot of equations here, and all the equations here are true. So it will ask, like, by giving you all this kind of stuff, let you to prove. Usually it will have a beta here, that is the thing you need to prove. For example, it asks you whether you can prove B here or not. So this is just the knowledge base. So how can we like prove this stuff? So here we have actually 3 different ways. So the first is what we call model checking. That is to list down all the possible solutions in truth and false table. Then we can tell them, okay, whether this is true or not, or under what kind of condition. So the conditions here are actually just all these things here. However, this method is absolutely not that efficient during exam, since all the equations in exam will be really, really difficult. So you have no time to list down all the possible ways. And one more thing to mention here, in order to prove the B, for example, here you no need to like use all of the knowledge base here. You can just use some of them or just one of them in order to prove it. The second is we called Inference Rules. So this, I would say, is the most important thing, and we have to really understand it. So it has 3 different things. One is modus ponens. This is, I don't know, probably some French. I don't know what does this mean. It's just like to eliminate something. So here I would like to have a basic example here, which is to say, so let me change the color here. If we have this, so it is exactly here. If we have this kind of condition in our knowledge base, and if we know another thing that is A here, so we can like present this like this. So we know both of them. One is if A then B, and we know A is true. So we know both of them are true. And we can derive that B is true as well. Since if A is true, then B is true. And we have another condition, that is A is true here. So if A is true, then B is true. So this is what modus ponens talking about. And I would just like to illustrate more about the difference between if A is true, then B is true, and just now the truth and false table we saw. So you may have like question about, wait. You say like if A, just now you say if A is true, if A is true and what's going on here? So if A is true and B is false, then this term is actually false. But why here if A is true, then B is true? So this is actually different. So just now the truth and false table we saw is actually by giving the condition of both A and B, then we calculate these terms truth and false, or you could say the Boolean value. However, here from modus pronus, it's actually talking about if A is true and A and B, this term is true, which is the result from our truth and false table just now, and we are going to derive the B here. So you remember if this if the term is true and if A is true, then B has to be true here. It cannot be false. So this is a difference. We have to pay attention to that. Okay, let's go back. Second thing here is the AND elimination. So what does this mean? It's basically if we have A and B here, and we know that, so let's say A and B appears here, okay? And we know this song is true. This sentence is true. So if we know this sentence is true, we can actually derive, wait, let me make it to be more professional. So the professional way is just to have a line here and put some stuff here. So if we know the A and B is true, then we can have actually two results. One is A is true, of course. The second is actually B. Since the only way to make the AND to be true is both of the terms here actually to be true. So I believe this is also very intuitive. The third thing is really, really important. That is logic equivalence. So I would like to refer this to our lecture notes. So here is the page for our lecture notes about the logic equivalences here. I wouldn't explain all of them. I just want to pick one of them, which I think is really important. And you have to understand it not just from the false and truth table. You have to really understand the meaning, this equivalence from back from its your understanding. So actually, to improve all of these equations, you can just use the false and truth table. So you just list down all the tables there, and to compare if they're the same, then these two equivalents are the same. These two sentences are equivalent. So here, just now we talk about the if-then sign here, which is, let's say, if alpha then beta, then how can we translate it? So just now you remember if alpha is false here, then no matter beta is true or false, this term will be true. If alpha is true here and if beta is true, then it's true. However, if alpha is true and beta is false, then this term is false. So how can we conclude this? So first is if alpha is false, no matter what beta's value, it will be true. The second is we are going to OR here. So here is OR sign. If alpha is true, then beta is true as well. So you could say like this. Then it will be true. However, since alpha here is true, then we can just ignore this and we just derive this form. So personally, I cannot remember any names for this kind of equivalence, but I would just, so for me personally, I would just suggest you to understand this meaning, and since it's really important when simplify those really complicated equations. So just to understand it, not memorize it, but to understand it. Last but not least, we have our third method, that is resolution. So resolution is, from my perspective, is somehow similar to inference rules. That is, you can use create of these methods to simplify your equation. However, the only thing here is you have to simplify your results into the Cnf form. So Cnf represents the conjunctive normal form. So here I would like to talk a little bit more about the Cnf form. So there are a few things. So first is for Cnf form. So for Cnf form condition. So first is you cannot have this either the equivalent sign or the if then sign. So you have to translate them by using the equivalence formula. The second is the negation sign should only be in the bracket, so you cannot have like A and B. Instead, you have to transform it by putting the negation sign inside the formula here. The third is you can only have this and sign between different brackets or you could say sentence, and you can only have the or sign in the sentence. So for example, this is a valid Cnf term. However, if let's say we change this or sign into and sign, then this is not. So yeah, there's just some very basic difference. So I would like to give you guys two examples to demonstrate, to illustrate these ideas. So first question is about the knowledge base. So we have two sentences here. So one is A is equivalent to B or C. Second is not A, and the question asks for you to prove the not B here. So first of all, we can start from the first sentence. So if you remember the equivalence, it should be transformed like this. Okay, so here we have a really long sentence. We have to simplify that in order to get a not B here. So if you remember the end elimination, so since we know this term is actually true, this term is true as well. So this, when transform it into equivalent form, we still know, okay, this is true. Oh, and one more thing, just about a syntax. Here we have to have the bracket, since you remember the and signs precedence is actually higher than the if and if then sign. If we don't have the bracket here, it would just like first B or C, then and B or C. So that absolutely makes no sense. Okay, so actually when we see the not A here, we really want to use the not A since it's another condition. So actually these two sentences here can be transformed. So the first one can be transformed as this, and the second can be transformed. So first, there are two steps. So the first is A. Just have a negation sign for both of them. Then we can use, later I will just say that. Okay, so first of all, okay, so if this is true, yeah, we know not A is true here. So we cannot say anything about the B or C, since we know this whole term, this term here is true. Yes, that's true. And this is true. Okay, so this is true, and here is all sign. We remember if one term in the all sign is true, then the whole term is true. However, we have the not A here, which is true here. We cannot determine anything about B and C here, and A does not offer any help to our final target. So here we just like, nah, you're not my friend. So the next thing here is this term here. So you remember if this is true, if this is true, then this is true as well. So here we can use the not A here. So if then yeah, we can have this is true, and moreover we can simplify it. Pay attention that when we move the negation sign in the bracket, we have to change the or sign to and sign, or from and sign to or sign. So just to change that. So we know this term is true, and so here, from here to here, we have a and elimination, and from here to our final target, we use another and elimination. Just a very quick review. If A and B is true, then both A and B are true. So this is the thing. So it's the first example. The second question is just to transform this form into the Cnf form. So you remember, so first of all, we cannot have either the equivalent sign or the if and sign. So first of all, we are going to transform it into this one, and don't forget the bracket here. So you can have different kind of brackets here, but for me, this is my preference. And when we transform the equivalent sign to if then sign, the next step we're going to do is we just simplify the if and sign. So if you remember, we actually have two different equivalents for if and sign. One is to transform it into an or sign, or just to change the position of these two terms and give them a negation sign. However, the second option does not help here, because we still need to cancel or eliminate the sign here. So what we're going to do is we choose the first option. So we just and here, or here. We can still have the bracket here, and we have a negation sign here, B, C, and A. Okay, so another question is coming. So for Cnf, we cannot have negation sign out of the bracket. So what we does to this form is we first put it in and change the or sign, and VA. So this term comes to here. However, another question we are facing right now is we can just have the and sign between the different terms. However, apparently here you can see here is an or sign out of this bracket, so that's absolutely not true. So what we're going to do is we just put this this A inside the bracket. So first is this one, then sorry, my bad. Here should be or sign, and C A, and we also put this term down. So we just simplify this term. Okay, so I think this is the end for the first part of this this week's tutorial lecture. I would say the propositional logic is quite difficult, and it's even more important when we are talking about the first order logic in the next lecture notes. So if you cannot fully understand all the equivalence and equations, I would suggest that you have to understand that, because if you don't understand that, then you have no way to understand the first order logic. That is even more difficult with more calculations in it. So hopefully this tutorial is helpful. If you have any questions, comments, please leave it below. Otherwise, I'll see you in the next tutorial.